channel. Last day we saw the chemical bonding of NaCl. Today we'll see some other ionic compound and along with some covalent compound also. So basically we'll discuss all the compound whatever it is given in the Dr. Dalal's book. Okay. So NaCl we have understood how they have formed and how sodium is donating the electron and chlorine is accepting the electron, then they form the ionic bond. Now first example we will see for calcium oxide. Okay, calcium oxide. So first what we need to know is that how many total electron, or you can say how many like atomic number of calcium, that is 20, right? So what will be the electronic configuration? Electronic configuration will be 2 8 8 and 2, right? So here what you are seeing is the configuration is 2 8 8 and 2. Okay, and for oxygen, if you see for the oxygen configuration, this is for calcium. For oxygen what it will be? 2 and 6, right? Because oxygen has only 6 electron, right? Sorry, oxygen has only 8 electrons, so it will be 2 and 6, right? This is for oxygen. Now what we are seeing is that calcium being a metal, it has a tendency to donate the electron, because we know metals are electropositive, right? So these things we have to remember. Metals are always electropositive. Okay, metals are always electropositive. That means they want to donate the electron to get the nearest inert gate configuration, and by this way they will get a positive charge there. So in this case what will happen? If calcium having 20 electron, the configuration is 2 8 8 and 2. Now what will happen? This will donate 2 electron to become calcium 2 plus. So now the configuration will be 2 8 and 8, and you know this is basically total 18 electron. So who has 18 electron? That is argon, right? Argon has 18 electron and the configuration is 2 8 and 8, right? Now calcium, after donating the 2 electron, getting the configuration like argon, so it's basically attaining the stability because it is getting the inert gas configuration, right? So calcium, it's becoming calcium 2 plus. Now what will happen for the oxygen? Oxygen non-metal, so generally they are electronegative. That means they can accept electrons to gain the stability, right? How it will happen? If we see for in case of oxygen has 8 electron total, so 2 and 6, this is the electronic configuration. Now if it is accepting 2 electron, then it will be oxygen 2 minus, and now the final electronic configuration will be 2 and 8. So who has this configuration? Neon has this configuration, because neon, you know, that has 10 electron basically, and the configuration is 2 and 8, right? Now both the things like that calcium and oxygen, both the element got the nearest inert gas configuration. Now you see in this stage means one is cation and another one is anion, right? So they will come closer and they will have a electrostatic attraction kind of things. Now how it will happen? If we draw the dot structure, let's say calcium having this 2 electron here, okay, and for oxygen having 6 electron in the outermost orbital, 1 2 3 4 and 5 6. Okay, now what it is going to happen is that calcium is going to donate these 2 electron, okay, to fulfill the requirement of oxygen. So what is the requirement of oxygen? To get 2 extra electron in their outermost orbital, okay, and by this way calcium also will get the stability, because then calcium also will have that inert gas configuration like argon, right? So what will happen? This 2 electron it can donate here, okay. Now how it will look like? If you see, now see calcium become calcium 2 plus. Okay, oxygen if you see, previously it was 1 2 3 4 5 and 6, and 2 electron it got from calcium. It is like that. So oxygen having total 8 electron, and oxygen become 2 minus, right? So these 2 plus and 2 minus, they are basically cation and anion. So if they are coming closer, they will have a electrostatic attraction. Okay, because of that they will form this ionic compound, which is calcium oxide. Okay. Okay, fine. Now we'll move forward to to draw the other structures for other like ionic compound, whatever it is given in the book. So next example is for magnesium chloride, right? Magnesium chloride. So now quickly we'll do how many total electron magnesium has. It has total 12 electrons. So the configuration will be 2 8 and 2. This is the metal. Okay, so it has 12 electronic configuration. Now in case of chlorine, we have to see chlorine has how many electron? Total 17 electron, right? So the configuration will be 2 8 and 7. Now what will happen? Now if you see magnesium, if we are drawing the dot structure, 2 electron is here. Okay. And for chlorine, 1 2 3 4 5 6 and 7. Okay. Now the thing is that, see, magnesium, if it is donating 2 electron, then only it will get the inert gas configuration, because then only it will have 8 electron in their outermost orbital. Okay, so it has to donate 2 electron by any chance. If it is donating 1 electron, that is not going to give the stability to magnesium. So what it can do, it has to donate 2 electron, but chlorine can accept only 1 electron, right? Because chlorine has 17 electron, and 7 electron it is there in the outermost orbital, so it can accommodate only 1 electron to gain the stability. So what is the solution? The solution is that magnesium now can donate 2 electron to 2 different chlorine element, right? Different chlorine atom. So another chlorine can come here having 7 electron in the outermost orbital. Now you see, now what we can do, yeah, this electron we can place it here. Okay, so now magnesium can donate this 1 electron to this chlorine atom, and the remaining another electron can donate to the other chlorine atom. Now what is the final scenario it is happening? See, magnesium becoming 2 plus, because 2 electron is donated. So magnesium is 2 plus, and you know, if magnesium is donating 2 electron, then only it will get the nearest inert gas configuration, which is neon like, right? Neon has 10 electron in their outermost orbital, right? So magnesium is now magnesium 2 plus. Okay, so what chlorine is getting now? So see, previously it was 7 electron, 1 2 3 4 5 6 and 7, and it got 1 electron from magnesium, right? Now chlorine become chlorine minus, because only 1 electron it accept. So as it got only 1 electron, so 1 negative charge it will be placed in the above of the chlorine atom. Okay, for this side. Another side also similarly, the other chlorine atom having 7 electron previously, and now it got the another electron to get the 8 electronic configuration, and finally it is having the negative charge, right? Now this magnesium can make a ionic bond with these 2 chlorine atom, and if you see the electronic configuration now, the final electronic configuration, it will be 2 8. 2 8 means it's like neon, and here in case of chlorine it is 2 8 and 8, this like argon, right? This chlorine atom also 2 8 and 8, right? Now this magnesium, it will be coupled with this 2 chlorine atom to give the final salt, which is magnesium chloride. Okay, so these are the for the like ionic compound formation, how it is forming. So we can have some other examples also. We can try for like KCl, or let's say any other salt we can try, right? magnesium oxide and all those things you can try. That you can do as your homework. Okay, and whatever, like if you are not getting or if you are not answering, you can comment in the comment box, that I will try to solve the problem. Please subscribe to this channel. Then what will happen, slowly we'll cover all the chapter from class 9 ICSE board. Okay, and what are the chapter is needed to discuss first, that one also you can mention in the comment box. Please do not forget to hit the like button. Okay, so that will help me to understand ki it is really helpful or not. Okay, so thank you so much for watching the video.